now?
Yes. Can you see my presentation now?
Yeah, I can see it.
And can you see it in full screen?
Yes, now it's in full screen.
Thank you. So I managed to fix it. It was a bug that I had to go to the settings basically. Good morning everybody in the UK and good afternoon in China. So I'm Sally. I'm a lecturer in environmental design at the University of Sheffield. I'm the co-director of postgraduate taught programs in architecture and also the program leader for master's degree in sustainable architecture studies. What I'm going to do today is to discuss two different parts to my discussion. One is my research background because of the future collaborations. As I understand, the purpose of this workshop is to encourage future collaborations, and I thought it doesn't seem fair just by introducing one project to attract that, and I wanted to encourage that specifically that I really enjoyed your presentations, talks and research you have done, so I want to encourage that. And then I'll expand on the talk today. So in terms of my research background, I put it into a scale, into urban scale, building, technology, and going down to individual occupants. So I'll talk about it and give brief examples of each. And then I'll go to the talk. The talk itself is actually a book chapter, which is coming out in the book called The Handbook of Resilient Thermal Comfort, edited by Professor Surov, Fergus-Nicol and Home Rijal. It is going to be published soon, hopefully before the end of the year. So in case you wanted more in-depth information about that part, that is coming out, or contact me and I'll discuss it with you. So the talk will be our book chapter between myself and Professor Home Rijal. So the background in research in terms of urban areas, I'm afraid is very limited. Mainly my collaborator, Dr. Diana Nasir from University of Leeds, about urban canyons and how to harvest the energy through road solar collectors. So it has some similarities to the work of Mohammed, but probably Diana is the best person to talk about. In terms of buildings, balancing energy and comfort, building design and typology, cellular or open plan offices. So this was my PhD work at University of Edinburgh. So what I did was comparing open plan offices in the UK with low levels of thermal control to personal offices in Norway with high levels of thermal control. And we found very energy efficient buildings in the UK compared to Norway, while the users' views and comfort was much higher in the Norwegian basically building. And so how do we manage this balance between energy and comfort? And this introduced us to the next project, which I will introduce to you in a minute. So mixed mode versus air-conditioned offices. This is the topic of today's talk. So I'll let you hang in there. I'll come back to that soon. In terms of technology, so we worked on wind catchers, personal comfort systems, and energy harvesting systems. Wind catchers, this is mainly the work of my colleague, who is also chairing the session, John. And this is when we work together as postdocs in the University of Leeds, which is why I really enjoy collaboration. That's why I encourage you to contact me, because I appreciated the work we did together. I found it much more energetic, fun, and also productive, innovative. It was really quite an impressive time for me, and I would like more collaborations. And I've got a lot of collaborations I'll introduce later. So what does that mean? So retrieving something like traditional techniques, which is used in hot and arid climatic conditions, and adapting it to temperate climates as wind catchers, and then in order to adapt to the climate, to introduce the heat exchanger, and then of course John has done the CFD and also the wind tunnel as well analysis. Personal comfort systems. This was at the back of my PhD work. So after being in the open plan office, so how do we fix it? Of course, people are going to be unhappy. So this was how this was introduced. Again, I worked with John on this project as well. So thermal chair, a chair that could have heated seat and back, was some of the ideas. So providing equipment to people so that they can adapt their workstation to what they need. And that was the idea. And we reached much more comfortable and satisfaction levels. This is very much comparable to results I found between Norway and the UK. So just by introducing a thermal chair, we could increase occupant comfort to similar levels. So that was quite a good result. In terms of energy harvesting, heat sinks for wearable thermoelectric generators. This is mainly the work of my PhD student, Zohre. So it's like similar things to a watch, but what it does is transferring the body heat from human to electricity to be used for devices or heating garments, perhaps. The next level or scale of basically research is individuals. A human-centric approach, that is really my passion. And through that, I even go to the different scales of building or technology as well. So I really endorse individual differences, and I like it to acknowledge them in the design of the buildings and technologies, and appreciating and understanding user behavior. So quite a few projects here, from ethnography and also collecting data for a year and understanding how people behave and what they want, and also methodology I introduced, which is visual thermal landscaping, mapping people's actions and what they want, their views, to the actual plan, because I come from architecture, so I wanted to see people in the spatial environment, in connection to the building and to each other, so close proximity to the windows, and how people sat next to each other would feel so differently, and embracing and acknowledging that, basically. And human psychology, so this is the work we are currently doing with Professor Marcel Schuyke from Aachen University and Dr. Fusha Siras, who is a psychology, basically researcher from University of Sheffield, where also I'm based. So it's all about how this individual differences is shaped by psychology, and how does that work in terms of, in the context of thermal environment, indoor temperature, basically. So that brings us to the topic of today. Before I start that, so in case you found any relevance to any of these projects, please do contact me. I encourage future collaborations, whether for introducing projects or papers or funding. I very much welcome that. So mixed mode versus air-conditioned buildings, offices. I go through it quite briefly. The book chapter, as I said, is coming out, so further details will be in it. So first, to talk about what is a mixed mode building. So in mixed mode building, basically we have summer, winter, and autumn versus autumn/spring. Sorry about that. That's the clock we have. So we have summer, winter, and spring/autumn, basically. Performance. In summer, the building is in a cooling mode. In winter, it is in heating mode. While in spring and autumn, it will be mainly naturally ventilated system. Fully air-conditioned sealed box is lacking that natural ventilation, basically. It switches from summer cooling to winter heating. Now, having said so, it doesn't mean that we have got an air-conditioned building with openable windows for a mixed mode building. It's much more sophisticated than that. I'll come back to this conversation, so it should not be mistaken by simplifying it to just adding openable windows. So why is the topic today important? Because recently most buildings are moving towards fully air-conditioned sealed boxes. Even at our university, University of Sheffield, most of the recent buildings are fully air-conditioned sealed boxes, quite expensive to build and all that, but at the same time they are lacking that connection to outside. They are lacking that satisfaction of people opening the window. So I'm in the Arts Tower, which is an old building, quite a pleasant building, and one of those beauties of this building is the openable windows. So it's naturally ventilated, and when I feel warm, I just open the window in my office. It's much more comfortable than when I go into the more recent buildings in the university, and that is I can see that more and more air-conditioned buildings are being built. So that's why this topic became so important for us, Hom and myself, to discuss. So fully air-conditioned buildings basically have no openable windows, and so the windows cannot be opened. So mixed mode office building in terms of energy efficiency. So basically, because it's naturally ventilated half of the year, it has the potential to reduce the energy quite massively. So that's quite important. However, as I mentioned before, it's not an air-conditioned building with openable windows. Otherwise, what you will find is the energy will go out because occupants may have their AC on and all of a sudden they feel like fresh air and open the window, or the heating is on and they feel like it's too warm and open the window, and all the energy that has been built up will go out. So it's much more sophisticated than that. So how do we do it? The use of smart systems can be quite useful. I don't go into depth in it. I just show you a glimpse of some of the opportunities. So there are variations of mixed mode designs. You can look at it in the work of Gail Brager and also Sipsy. The references are at the bottom if you wanted to follow this. For example, I'll just give you an example. In the changeover basically system, technology plays a part. So external temperature sensors, internal window opening sensors, and automated louvers. So basically, if an occupant opens the window, for example, the system detects it and changes the heating or cooling system that is in operation. For example, in concurrent system, when the air conditioning is on, if somebody opens the window, the system automatically puts the air conditioning either to the minimum as a background or turn it off, so that no energy will be wasted, basically. So it's much more sophisticated, as I said. So the work we did was basically field case studies of thermal comfort, and we went to the actual buildings in 3 countries, Japan, Sweden, and Norway. 13 office buildings were examined, and nearly 5,000 data sets were collected and researched, basically. Our analysis went into 2 separate parts. One was statistical analysis, mainly on the Japanese data sets, and one was the visual thermal landscaping model, which I talked about earlier, which we applied it on the Swedish and the Norwegian data sets. So talking about now, what did we find in these buildings, the mixed mode versus air-conditioned offices? In terms of temperature ranges, what we found was indoor and outdoor temperature ranges were quite different, and I mean indoor mainly. So in the mixed mode building, there was quite a wide range, over 12 degrees difference range in terms of temperature. However, in the HVAC building, we have much more narrower range, kind of half of that, 6 degrees. And yearly temperatures And the above mentioned one is all buildings put together. Now, if we separate the buildings, we can see that yearly temperatures, let me show you with the laser pointer. So as you can see in the yearly one, what we have got is each building in the air-conditioned building has a very narrow band all throughout the year. So regardless of the season, the temperature inside the building remains the same. While in the mixed mode building, you can see a much variety and wider range of indoor temperatures, working more with the seasonal changes, which is much more visible here, as you can see, as compared to the air-conditioned building. So a much wider range, basically. In terms of users' views, we didn't find significant differences in the Japanese case studies. In terms of user behavior, what we found was that occupant surveys showed us that in the air-conditioned building, more passive behaviors were used when feeling hot, and in the and this could be even during the summer and or winter. And in the mixed mode building, passive behaviors when people were feeling cold, such as eating or drinking something warm, using a blanket, putting on a layer. However, the observation, so we did some observation on site as well, that showed us much more adaptation of the building in the mixed mode building using those thermal controls. So windows were used 15% of the time, and fans 20%, local heaters 11%. And these facilities were not basically available in the air-conditioned buildings. A little bit of maybe local heaters, but not much else. Visual thermal landscaping. So in the Norwegian and Swedish buildings, we did apply this to understand the information more in context and according to meaning. So what we found was that in the mixed mode building, variations of indoor temperatures were used, as you can see. So each room has a different temperature, and this is despite the orientation of the room or solar gain. And occupants adapted to their individual needs, adapted the environment to their individual needs. And as a result, they had much higher comfort level, 16%, and much higher satisfaction level, which is 28%. In the HVAC building, a much more this is the bottom one. As you can see, the whole floor is one color only, so it's much more uniform and also consistent thermal environment, because we did it throughout the day. So all throughout the day, it was consistent while the mixed mode was varying. No room for accommodating individual differences. And the interesting part is when you see people sat close by and sharing a space, and then they have such differences of opinions in terms of what they think it should be and what they prefer. So basically 60% of the people preferred a change in the thermal environment, mainly slightly warmer to much warmer in the summer. So the study was done in the Swedish and Norwegian buildings in the summer, and they wanted it to be warmer, suggesting the building was being cooled too much. And also an observation which was also confirmed by the interviews was women did not wear skirts or dresses, not because they didn't like it, but because they found the office uncomfortably cool to wear skirts or dresses. And also they would put on layers to walk in the building in summer, and they would take it off, then they would go out feeling, oh, it's summer again. So suggesting extra energy was used to cool the building during the summer, basically. So in terms of energy use, we found contradictory, basically, information. So the mixed mode building in the Norway was using way more energy than the Swedish building, which was air conditioned, despite that it was cooling down too much. However, in the Japanese data set buildings, we had 20% less cooling because of the openable windows. this again takes me back to the design of the building. So it's much more sophisticated. In the Norwegian building, what I found was that the windows were left open while the AC was full on, and that costed a lot of energy. So it needs to have a care in designing the system itself, and smart systems, as Xiang was discussing, the smart systems, for example, maybe they can be accommodated much more cleverly in the design of the mixed mode buildings. In terms of health, so what we found was much higher health conditions in the mixed mode building, 23%, except tiredness. I never got to understand why people were more tired in the mixed mode building. Maybe it was the nature of the work they were doing, but overall they felt much healthier. So what did we learn as conclusion? So again, the book chapter goes into much more detail. I'm going to skip through all of that, just going to the conclusion. So it's about resilient thermal comfort, basically, buildings. So future resilience, so mixed mode building is much more resilient in terms of human comfort, thermal comfort, knowing that our expectations are rising and we have the latest technology at the tip of our fingers. We do expect it to be comfortable. The problem is, if people are not comfortable, they are going to do something about it, which will cost much more energy. So it's best if the building itself is accommodating that. In terms of energy, as you saw, we had contradictory findings, which is suggesting that mixed mode has the potential for saving energy for half of the year due to natural ventilation, but extra care is needed there. In terms of so thermal comfort, mixed mode was much better, much more adapting to seasonal changes, outdoor temperature, much more comfortable, allowing variety of adaptive satisfaction level quite considerably. In terms of health, mixed mode was much healthier. And coming back to the conversation about the COVID, so WHO recommends the use of natural ventilation during the COVID situation, and we all wanted to be next to some fresh air, basically. So, and a sealed box may not be the good solution for future building resilience, specifically considering future pandemics. So perhaps coming back to mixed mode may be a much better idea. In terms of energy, so again, mixed mode has the potential, but extra care is needed in designing it. So thank you very much for listening, and also I hope you found some areas for collaboration. In case you wanted to contact me, I welcome that. So thank you very much. Handing over to you, John.
Thank you, Sally. Thanks for sharing all those research work that you're carrying out. I'm sure you'll find, I mean, our audience will find some areas that they can collaborate with you. And I can see some questions in the chat there. I think we can discuss it later in the discussion, and something about the chair as well.